Good afternoon, students. So now in today's class, we have to discuss with that FP growth algorithm. So in the FP growth algorithm, first we have to, it is an alternative algorithm for the frequent item sets. We have to find out with this algorithm, that is the FP growth algorithm. FP growth algorithm, mainly we have to use it for the to discovering the frequent item sets, the frequent item sets. So far in last classes, we have to discuss with that a priori algorithm. With the a priori algorithm, by using the joining and pruning steps, you can find out the discovering the frequent item sets. Similar way, you can use this algorithm. You can find out the frequent item sets with the FP growth algorithm. In the FE growth algorithm, mainly we have to use one data structure you have to use, that is the FE tree. FE tree is simply you can use it for the extracts the frequent item set directly from this structure only. So what is the FE tree representation? How we can represent? Mainly it is a compressed representation of the transaction database. For example, you have to see the prefix tree data structure is used here, and each transaction of the path of the inter tree can be overlapped. Once the FE tree is constructed recursively and divide and conquer FE growth algorithm, you have to use it to enumerate the all frequent items. Generally here we have the more paths overlap with one or two another is the more compression when we can be achieving the using the FE tree structure only. So here if the size of the FE tree is small enough to fit into the main memory. So this will allow that to extract the frequent item sets directly from the structure in memory instead of making repeated passes through data stored on disk. So see this FP tree construction, how you can you construct the FE tree. In the FE growth algorithm, mainly you have to use it first construction of the FE tree. So FE tree mainly you have to use the prefix tree, you have to use it here. So this is the total, we have to consider the 10 transactions, that is the AB, BCD, ACDE, and here these are the items A, B, C, D, E. These are the items. These are if out of 5 items for each transaction, they are which items they have to purchase. Clearly, it mentions. So here that is the since the transactions are sets of items, we need to transform them into the ordered sequences so that we can have the prefixes. So here you can say see here this is the total 10 transactions we have to process it, and each transaction, that is in first transaction AB items only they have to purchase, and similar way second transaction they have to purchase it the BCD items. Like this way you have to purchase it the 10 transactions in various items they have to purchase in the transaction data set. From this transaction data set, how we can implement the FP tree, that is the here we have to see first how to implement the construct the FP tree. Initially the tree is the empty, so that we have to represent it as null. So so you have the transaction data set, that is the 10 transactions you have. In out of 10 transactions, first using these 10 transactions, we have to construct the FP tree. First, initially the tree is the empty. That means no items are there in that tree. That is simply can represent it as null. So first transaction, that is the AB. That is the items you have to use it the AB items only. You have to purchase it by the purchased in first transaction. So now you have to write A equal to draw the left hand side. That is the prefix you have to use. A prefix means that is simply you can use root. That is the root and left and right. Okay. So here you can use that null. That is the you have to represent it as null. Null to what are the items you have to purchase A, B. So now you have to use A is the 1 and B is the 1. This is the way you have to write. So here like this way you have to draw. So this is the null, that is the transaction 1, and A is the first, only A is used once only, that is the one you have to represent it. P is used only once, that is the B is represented. So this is the left height you have to represent the node label is item support. So in each node, the tree has the label consisting of the item and support the number of transactions that is that node and follow that path. So first transaction is completed. Then second transaction. In the second transaction, we have the BCD. So in the BCD, how we can draw the how to construct? Here we have to consider first item is B, so you have to consider here, and the right side B is you have to represent it as 1. So that is another transaction. B is 1. Then C equal to 1. That is the C is also you can use once, and D is also 1. This is the second transaction we have to complete it. So here we add the pointers between the nodes referred to the same item. So manaki once whenever this is the AB is the first transaction, BCD is the another transaction, but B is repeated here in another transaction. So now you can you have to write the node to the B to B. That is the B1 and P1 you have to represent it here. Then this is the second transaction. Next, third transaction, that is the ACDE. So how we can write? That is the ACD you have to represent that. So first one you have to represent the transactions here. So you know that header table you have to use the pointers. How we can represent the pointers? Header table, that is the items A, B to E and its pointers A, B, C. So A represents the one pointer, B is the another representative. So B here we have to represent the 2 points. That is the B is equal to 1. B is represents the 2 points here, and C is represents 1, and D is represents the 1, and E is represents the in another way. So only 2 transactions only we have to consider here. We will take the third transaction. See here, whenever you have to consider the third transaction, reading the transaction, if null equal to A equal to 2 and B equal to 1 and B equal to 1 and C equal to 1 and D equal to 1, this is the second transaction he has completed. Whenever you have to consider the third transaction, A, C, D, E. So now we have to consider. So this is the similar way of second transaction we have to complete it like this. Once you have to complete the second transaction and third transaction, first which item you have to start it here. So A is started. Now A will be support is only 1, that is incremented 2. That is the A value. A is support to 2. Then C is you have to write you have to draw the link. So C is will be assigned to here. This C1 and this C1 both will be added. And next D1 again you have to draw. Link will be added, and similar way E1 is treated after transaction. So it's like this way you have to process all the details here, like see here. This is after third transaction you have to process here. You can get like this. So A, C, D, E. So A is will be assigned to. So A is repeated the second time. So that you have to represent it as A is will be assigned to 2, and then C, and then D and E. So now C1 is linked with the C1 of the second. D1 is linked with the D1, and E1 is linked with the you don't have only C and repeated here. So that only that links are linked with the C1 and D1 and D1. No other links, no other items you don't want to link here. So after the completion of transaction 3, you can process like this. That is the way you have to construct the FE tree. And see here, this is the links you have to C1, D1, D1. Okay. Clear? Then finally, we can process it here like this. After 10 transactions, you have to process. That is the A will be assigned. How many times A will be repeated? So first one A is repeated once. See here in the transaction data set. First transaction A, and second transaction 2, fourth one 3, 3, 4, 5, eighth one 6, ninth one 7. So totally A will be support will be assigned to 7. So 7 A is started with the 7. Next one, what is the B we have to represent it? How many times B we have to repeat it here? B here and B here. 2, 3, 4, 5, 6, 7, 8. So here we have the two B's are represented. One B you have to represent it with the 5. So second, another B you have to represent it with the BC. Whenever you have to consider that time, you have to consider this one. Whenever you have to consider with that A, B, C, that time you have to consider this left hand, left side tree you have to consider. Whereas you have to consider the BC only, that time you have to consider as right side tree, uh, tree only. So like this way, we can process here. We can get the pointers after use it to assist the frequent item sets. So this is the way you have to finally FE tree you have to construct it after 10 transactions. So easily you can draw here. First one, that is AB, second transaction BCD, third transaction ACDE, and fourth transaction is ADE, fifth is ABC, and sixth is the ABCD, and seventh is the BC, eighth is the ABC, and ninth is the ABC ABD, and 10th is the BC. So which item is starting with that? From that place you only have to consider here. So first is the AB, you have to consider here left hand side, and BCD is considered as the right hand side. Then third transaction A is considered. So left hand side you have to consider A, and you have to draw the line CDE. Okay. Then fourth one ADE. So ADE. So you have to consider the left hand side A and DE. So you have to consider here. Then fifth one is the ABC. ABC again already is there. So no, don't want to draw any line. Next one, A, B, C, D. So automatically the support will be incremented. Next one, A, B, C, D. So A, B, C, D is represented as, so first one have to represent the support will be incremented. D1 is always 1. D is only once you have to get in here. So D is 1. Then BC. BC you have to consider as right hand side here. B is starting with the B. So right hand side BC, that is the B value is already 1 and C value is also 1. That is incremented to 2, 2. Okay, clear? Then ABC, ABC and the left hand side, ABC. So automatically you have to increment the support. Then ABD. So this is the ABD you have to consider ABD. D is you have to consider as D is 1 here. In B, B item side, you have the right hand side here. So C is the left and D is the right. You have to consider that is the ABD. Then last one is the BCE. BCE you have to consider right side and right hand side. That is the BC is incremented to 1. That is the support is 3, and C is also supported is 3. Then E1 is you have to consider E is only once, that is the E1. So every point E1 to E1, B1 to B1, C1 to C1, D1 to D1. Like this way you have to consider. You have to linking that all the. This is the way you have to construct the FP tree. After constructing the FP tree, now how to find out the FP tree size? Every transaction is the path is the FP tree. The size of the tree depends upon the compressibility of the data. So extreme case, we have all the transactions are the same. The FP tree is the single branch. And extreme case, all transactions are different. The size of the tree is the same as that of the database. Bigger actually, since the need additional pointers. Uh, So now we have to represent the item ordering. How we can ordering the items? So here you can ordering the items. See here, the size of the tree is also depending on the ordering of the items. Heuristic order of the items according to their frequency from the larger to smaller. We will need to do an extra pass over the database to count frequencies. Example, T equal to that is the AB first transaction, and you have the 10 transactions. Now we have to ordering here. That is the OA, that is the number of counts of A is 7 times, and B is the 8, and C is the 7, and D is the 5, and E is the 3. Now ordering is highest to lowest. We have to represent it here. B is you have to starting with the B, and A is the AC, and D E like this. So from highest support to lowest support. That is the you have to represent it here. The items are you have to represent, that is the BA, BCD, ACDE, ADE, ABC, ABC. Whenever the A is there, that is starting with the BAC. So always B is started with the B. Here in previous items, transaction, 10 transactions, we have the starting with the A. So some cases are starting with the A. So always you have to replace with that, starting with the A in the place of A, you have to replace with the B only. So see this transaction item data set. In transaction data set, always you have to starting with the B only. Clearly it shows here. If that B is not available in that data set, that is in that transaction, you don't want to consider. Remaining all cases, you have to starting with the B only. That is the item ordering we have to perform in the frequent item sets. That is in FP growth algorithm. See here, that is the finding the frequent item sets. That is the consider the all the data sets you have to represent it here. EDCBA and divide conquer method. So here you have to use it here. See here. This is the frequent item sets. All the items you have to represent it as EDCBA, and now you have to represent it starting with the whenever the E is available, that is the D, C, B, A, and D is represent CD, BD, AD, and C you have to represent BC, AC, and B is represented as AB. A you have to starting with that. We don't want to here. We have to consider. Then CDE, then BDE, then ADE, and BCE, ACE, then ABE, and CD you have to represent BCD, ACD. You have to consider, and BD, ABD. So then BC, ABC you have to consider. Like this way, you have to draw the frequent item sets. That is the finally you can get the ABC total item sets. You have the ABC. So this is the only you have to consider the frequent item sets. That is the E, D, E, C, D, E, A, C, D, E, and then BCD is a frequent. So A, B, C, D. We can generate the all data system set in this way. Expect the FP tree to contain the a lot of less. So finally, you can get like this using the FP tree to find the frequent item sets. So this is the FP tree. So this is the way we can draw the FP tree. So once you have to draw this diagram, that is FP tree, with the finding all frequent item sets. Now starting with that, which is the highest, that is the only you have to consider here. That is the B is the highest, you have to represent it. We will see the how to compute the support and possible item sets. You can represent it with the A, B, C, D. So that pointers you have to represent it. So which one is the adding? So intersects ending with the A, intersecting ending with the E. In the that cases you have to consider here, and intersecting ending with the T, that is considered here. Ending with the C, that is you have to consider here, and ending with the B, that is you have to consider here. So where the ending with the B, that is the light draw line. So remaining all lines we have to draw with the red, but in this case we have to light black. We have to represent that line ending with the B. So ending with the A, that is the you have to represent the A is the 7. So this is the finding the frequent item sets. So this is the algorithm for the FP growth. For each suffix x, phase 1, construct the prefix tree for the x shown before, and compute the support using the header table and the pointers. And phase 2, if the x is the frequent, construct the conditional FP tree for x in the following steps. Recompute the support and prune infrequent items and prune leaves the recurs. So this is the example for the constructing the prefixing tree. So just you can draw this constructing the FP tree. See here, this is the constructing the prefix tree. Step by step computing the supports. Recompute the supports. Step by step process. You can perform it here. Finally, you can get that value. So where the nodes of only one, you have truncated those links are you have to truncate it and delete the nodes. And this is the step-by-step process. If we conditional FP3 can perform here. So finally, you can get the null. So this is the overall view of the ending with the D. Two nodes and the pruning. So like this way, you have to process it here. This is the FP growth algorithm. The efficiency of an algorithm depends on the compaction factor of the dataset. If the tree is busy, then the algorithm does not work well. It increases the lot of number of sub-problems that need to be solved. This is the overall view of the various research activities in association analysis. Mainly, you have to represent research issues in mining association patterns, conceptual issues, implementation issues, application issues. So these all we have to represent the summary, overall summary of the various research activities in association analysis. Theoretical formulation, types of patterns, data types, database issues, pattern discovery, constraints, processing, domains, other data mining problems, rules, item data. In types of patterns, so generally you have represented with the three ways: rules to item sets and other structures. And pattern discovery, you have to represent the computation model and algorithm and data structures model. That is the FP tree. Mainly, you have to use it in pattern discovery only. And post-processing in the visualization and interestingness, measures method, ranking, filtering. So once you know, this is the overall view, that is the summary of the various research activities association analysis. So conceptual, implementation, application. So if you have any doubts regarding to this one, this is the end of the FP growth algorithm. We'll continue in next class with that uh, frequent item sets. Frequent item sets mainly we have to use it the two algorithms, that is the a priori and FP growth. So along with the examples we have to discuss so far, we'll continue in next class with the correlation analysis. Uh, so all of you listen, everybody. Everyone must submit the assignment first of June, before the submit all of you June 1st. Okay. So who are the submitted the assignments? Those people only getting the marks. Otherwise, we'll put the zero for the assignments. So all of you must submit the assignments on June 1st. Soft copy you have to include the on Google Classroom. So already I gave link WhatsApp group. So everyone you have to check it out and you have to submit the assignments before first. Okay. Thank you.